So let's use what we've learned in the previous lesson to launch a new MySQL database container with Docker that the application will connect to in order to store and retrieve users' data. To launch a MySQL container, we can use the following command where the e-option flag is used to set environment variables that will only be accessible by the applications running within the container, which in this case is the MySQL database. Once executed, this command will run a container in the background, publish the port 3306 used by the database, set the root password to root, create a new database named authentication, and create a new user named admin whose password is also admin. As a side note, when in production, I encourage you to make these values a little harder to guess in order to improve the overall security of your application. Finally, let's run the docker ps command to make sure that the database container is up and running. Now that our database container is set up, the first thing we're going to do is update our configuration file in order to include the environment variables relative to the database. So let's open up the development configuration and add the database name, the username, the user password, the address of the host the database is running on, the port the database is listening to, the dialect of the database, set the database logging to true so that every operation performed on the database by the object relational mapper are logged in the terminal in the SQL format, and finally set the synchronization to true so that the changes made in the code are reflected on the database itself. Once we've done that, we're going to open the environment loader module and update the environment object by adding a new database property to it that matches the variables parsed from the configuration file. Here, it's important to note that since the .env module parses every value as a string of characters, we have to manually evaluate the logging and sync properties using the strict equality operator in order to convert them into actual Boolean values. Sequelize is a Node object relational mapper, also called an ORM, that features solid transaction support, relations, eager loading, and read replication, among other things. Depending on the type of database you're using, Sequelize requires an additional component named a database driver, which is a computer program that implements a protocol for database connection. In the case of a MySQL database, this driver is called MySQL2. So let's start by installing both. Now that our environment loader is all set, let's create within the loaders directory a new file named database that will be in charge of instantiating a new database handler. Within this file, let's start by importing the Sequelize package and write a module that exports an asynchronous factory function that takes as argument the environment object containing the database information. Within this function, let's right away explode the database object using the destructuring assignment syntax so that we can more easily use the variables it contains. Once we've done that, let's create a new database handler by instantiating the Sequelize class exported by the Sequelize module using the database name, the username, and the password, and an object containing the host, the port, the dialect, and the logging flag. Now that our handler is ready, we're going to use its asynchronous authenticate method in order to perform a connection attempt, and we're going to return the database handler itself so that it can be used by the rest of the application in the following steps. Finally, we're going to import the database loader into the application's entry point and initialize it like any other loader within the try-catch block using the await keyword so that any failed connection attempt is automatically caught and properly handled by the application.